Hello everyone. In today's video, we will explore the timber harvesting and processing industry, a crucial field not only for production, but also for its significant impact on the economy and the environment. We will also delve into high-quality wood products from the United States, a country renowned for its advanced technology and sustainability in the wood industry. The AFM 75 wood-cutting machine is a powerful and reliable harvesting head designed for processing large-sized timber. This equipment can be mounted on both wheeled and tracked machines, making it suitable for logging in large forests. The AFM 75 optimally combines power, weight, traction, and cutting force, making it an efficient tool for felling and handling large trees. This cutting head is equipped with 4 independent knives, enabling smooth trimming even for trees with large branches. The tree trunk is always held at the center of 3 cutting rollers, ensuring accurate measurement of length and diameter. The pressure of the rollers and knives on the trunk is automatically adjusted according to its diameter, allowing the cutting process to operate with optimal force and speed. The AFM 75 can work with various measuring and control systems, easily adapting to different base machines. With its robust design and high performance, the AFM 5 is an ideal choice for large-scale logging operations. Roundwood is sourced from FSC certified forests, ensuring sustainable harvesting and compliance with environmental standards. The logs are transported to the mill and inspected for characteristics such as diameter, length, and straightness. The wood is then categorized by type, e.g. white fir, ponderosa pine, and quality, premium, standard, or industrial grade. The roundwood is secured on a conveyor and fed into the sawmill. A laser sensor system measures the dimensions of the logs to calculate the most efficient cutting method, maximizing yield. The logs are cut into flat sections called rough slabs or smaller blocks, depending on production requirements. The rough slabs are fed through cutting machines to be divided into smaller boards, known as dimensional lumber, standard sizes like 2x4 or 2x6. Trim saws remove defective sections of wood, such as warped edges or cracks. Wood scraps from this process are recycled to produce wood chips or biofuel. The wood is carefully stacked into bins to ensure proper airflow and even drying during the kiln drying process. This step is crucial for reducing moisture content to the desired level, which enhances the wood's stability, strength, and resistance to warping or cracking. Once prepared, the bins are transported to the drying kilns, where the wood undergoes a controlled drying process to meet the specific requirements of its intended use, such as construction, furniture manufacturing, or other applications. The wood is arranged on drying racks to allow air to circulate freely between the boards. The kilns operate at temperatures ranging from 55 degrees Celsius to 80 degrees Celsius, maintaining the wood's moisture content at 6 to 8%, which meets industrial standards. The drying process takes anywhere from 7 to 14 days, depending on the type and size of the wood. The dried wood is fed through planing machines to smooth the surface and achieve standard thickness. The planer removes any rough patches or imperfections left from previous processes. Some types of wood undergo additional treatments, such as anti-termite chemical applications or protective coatings, to enhance durability and aesthetic appeal. Workers or automated scanning systems sort the wood based on criteria such as length, width, strength, and aesthetic quality. Wood that meets the standards is bundled into packages and wrapped in protective film to prevent moisture and damage during transportation. Wood that does not meet the standards is recycled or repurposed for other industrial products. Have you ever wondered where high-quality firewood comes from and how it's made? Join Neen Valley Firewood as we explore our sustainable and modern firewood production process. The process begins in sustainably managed forests. The wood is carefully selected from mature trees, ensuring no harm to the environment and allowing the forest to regenerate naturally. This is our commitment to sustainability and environmental protection. After harvesting, the wood is transported to the factory and processed into appropriately sized logs. This step not only ensures the logs are the right size for fireplaces, but also optimizes the subsequent drying process. The wood is placed in modern kilns where temperature and humidity are meticulously controlled. The goal is to reduce the wood's moisture content to below 18%, ensuring it burns cleanly, produces minimal smoke, and maximizes heat energy. Before reaching customers, each batch of wood undergoes strict quality checks to ensure it meets the ready-to-burn standard. The wood is then carefully packaged in various formats, from large bags and small bundles to loose cubic meters, catering to a wide range of usage needs. Wood splitting with a log splitter is not just a job. It is an art of resource utilization and a blend of human effort with technology. When we observe someone splitting wood, we don't merely see labor, but a symbol of perseverance, creativity, and harmony with nature. The image of a person using a log splitter embodies both the power of technology and the dignity of honest labor. It serves as proof that even in a modernized world, manual work retains its unique value and significance. The round wood cutting machine operates based on length measuring sensors and automated control technology, allowing it to cut the wood into evenly sized pieces according to production standards. The cutting size can be adjusted depending on the requirements of subsequent processes, typically ranging from 1 meter to 2 meters to suit the production workflow. Scanners or sensor cameras are used to inspect the size, length, and surface condition of the wood with precision and efficiency. After inspection, the wood is categorized into groups based on type, considering size and quality to meet the requirements of subsequent production stages. After classification, the wood is automatically transferred into the steaming chamber by cranes or conveyors, ensuring safe and continuous handling. During the steaming process, the temperature of the chamber is maintained between 100 to 130 degrees Celsius, depending on the type and hardness of the wood, to ensure optimal processing efficiency. The steaming time lasts from 6 to 12 hours, aimed at softening the wood and stabilizing its moisture content, making subsequent steps, such as veneer peeling, more efficient. Notably, the steaming chamber utilizes steam and partially harnesses thermal energy from burning wood bark or waste wood, contributing to energy savings and environmental protection. After being transported, the logs are fed into an automatic debarking machine, ensuring a fast and efficient processing operation. The machine's continuously rotating blades operate with high precision to remove the outer bark and rough surface, preparing the logs to meet the standards for subsequent stages. Afterward, the bark is collected and transported to a processing area, where it is effectively repurposed as fuel or processed into organic fertilizer. After being debarked, the log is placed into a veneer peeling machine, marking the first step in producing high-quality veneer sheets. The machine operates by rotating the log at high speed, while sharp blades precisely slice it into thin and uniform veneer sheets. After peeling, the veneer sheets are inspected through an automated system to evaluate their thickness, flatness, and surface quality, ensuring compliance with production standards. Standard compliant veneer sheets are then transported to the automatic sorting area, where they are neatly and securely stacked onto pallets, ready for subsequent processes. As for the excess or defective parts, substandard veneer or waste material is separated and transferred for recycling to be repurposed as raw material for the paper industry. The remaining core of the log, the central part that cannot be peeled further, is sent to a cutting and shaping machine, maximizing the use of the remaining wood material. After shaping, the wood core is typically processed into products for the construction industry, such as formwork timber, plywood, or other auxiliary products, catering to diverse market demands. After processing, these waste materials are used as fuel for the steaming chamber, contributing to energy savings and minimizing resource wastage. Veneer sheets are neatly arranged and fed into the dryer through trays or conveyors, handled with care to ensure their surfaces remain undamaged during the drying process, maintaining the original quality of the product. Key parameters such as thickness, size, and wood type are carefully considered to set the appropriate drying temperature and time, meeting the specific requirements of each veneer type. Drying process in the machine. The temperature inside the dryer is usually maintained at a stable range of 120 to 160 degrees Celsius, ensuring uniform drying and optimal efficiency for each batch of veneer. The drying time ranges from 6 to 12 minutes, depending on factors such as veneer thickness and initial moisture content. Achieving the desired dryness without compromising the veneer structure. Moisture control. The drying process is carefully designed to reduce moisture content from the initial level, approximately 60–80%, to 8–12%, which is ideal for subsequent processes like gluing and hot pressing. This ensures that the veneer is sufficiently dry, preventing warping or deformation during further handling and processing steps. The standard compliant veneer sheets, after inspection, are transferred to the glue spreading machine, a critical step in preparing for the hot pressing process. Adhesive is evenly applied to the surface of each veneer layer, ensuring optimal bonding between layers during pressing. Next, the veneer layers are stacked according to specifications, typically between 3 to 15 layers, depending on the required thickness of the final product, and placed into the hot press machine. The hot press maintains high pressure and temperature for a specific duration, allowing the layers of veneer to bond tightly together, forming large wood panels with uniform thickness as per production requirements. After the hot pressing process, the large wood panels are transferred to an automated machine where they are precisely positioned on the cutting table to prepare for the next processing step. With the assistance of laser sensors or advanced measuring systems, the machine ensures high accuracy in the positioning and dimensions of the wood panels before cutting. During the cutting stage, the panels are cut into standard sizes such as 600 by 1200 millimeters, 300 by 600 millimeters, or customized according to product design, meeting the diverse demands of customers. Any excess edges or scraps, if present, are removed and sent to the recycling area, ensuring minimal waste and contributing to environmental protection